In this video, we're going to discuss how to write a trigonometric expression as an algebraic expression. This is a skill we want to develop as we move into the study of calculus. And this problem states, write tangent of inverse cosine of u as an algebraic expression containing u. So we begin and we say let theta equal inverse cosine of u for 0 less than or equal to theta less than or equal to pi. Therefore, cosine of theta equals u for u between -1 to 1 inclusive. Right, now we can write tangent of inverse cosine of u equals tangent of theta. Our goal here is to convert the expression tangent of theta into a form that involves only cosine terms, since cosine of theta equals u, and this problem wants us to write an algebraic expression containing u. Now from the ratio identities, we know that tangent of theta equals sine of theta divided by cosine theta. So our expression tangent of theta we write as sine of theta divided by cosine of theta. Now since theta is between 0 and pi inclusive, then theta must lie in quadrant 1 or quadrant 2, and so sine of theta will be positive. Therefore, in our expression, we can write in the numerator sine theta as being square root of sine squared theta, and in the denominator, we still have cosine of theta. Next, from the Pythagorean identity, we know that sine squared of theta equals 1 minus cosine squared of theta. So our expression can be written now as, in the numerator, square root of the quantity 1 minus cosine squared theta, and then in the denominator, we still have cosine theta. Now that we have everything in terms of cosine of theta, and back in the beginning of our problem, we had written cosine of theta equals u, then our expression becomes square root of the quantity 1 minus u squared divided by u. So in summary, we have written tangent of inverse cosine of u equals square root of the quantity 1 minus u squared all divided by u. Then we could solve this same problem using a different approach, which would involve using the ratio definition of the trigonometric functions. So we would begin the same way, and we would let theta equal inverse cosine of u for 0 less than or equal to theta less than or equal to pi, and therefore cosine of theta equals u for u between -1 and 1 inclusive. So we want to find an expression for tangent of theta. Now we're going to draw two reference triangles containing an angle theta. And since theta is between 0 and pi inclusive, that means theta lies in quadrant 1 or quadrant 2. So we begin by sketching an XY coordinate grid containing a right triangle in quadrant 1 with reference angle theta, and a right triangle in quadrant 2 with reference angle theta. Now since cosine of theta equals u, and we know that cosine theta equals ratio of adjacent side to hypotenuse, then on both of our triangles we can label the adjacent side of theta as u and the hypotenuse as length of 1. So then cosine of theta equals u divided by 1. Now keep in mind, in quadrant 1 the value of u is positive, and in quadrant 2 the value of u is negative. So since we're looking to find an expression for tangent of theta, we need to label the side opposite of theta. Now let's begin by labeling the side opposite theta as b, and we want to get b in terms of u. So we can use Pythagorean's theorem and write u squared plus b squared equals 1 squared, and thus b equals plus or minus square root of the quantity 1 minus u squared. Now we know that b is going to be positive because theta is in quadrant 1 or quadrant 2. Therefore, b equals the positive square root of the quantity 1 minus u squared. Now remember, we're looking for tangent of theta, which we know is opposite side to the adjacent side, so we can write that tangent of theta equals b divided by u, and that equals square root of the quantity 1 minus u squared divided by u. So we have solved the problem, and we have written tangent of inverse cosine of u as an algebraic expression containing u. So in summary, we have tangent of inverse cosine of u equal tangent of theta equals square root of the quantity, 1 minus u squared, divided by u.